Why do stars fuse? So in a star, like that super bright one up there, there is so much heat and pressure. Right? So you've got this tremendous amount of material, this tremendous amount of mass, and gravity is pulling it together. So at the core, at the center, you have the weight of that whole star crushing down and creating this immense pressure, this immense temperature, right? As that pressure goes up, the temperature goes up. Now, why does that matter? So at the core, there's, at least in our main sequence stars, there's a lot of hydrogen. It's in its plasma form, so it's just a bunch of protons bumping around, right? So now to get to heavier metals, we need to take those protons, or rather the star does, smash them together. But protons both have positive charges. So you've probably played with magnets before. So if you try and take two magnets, and you're going to have a north and a south pole, or your positive and your negative pole, and if you try and put the same poles together, the same charge together, they repulse, they push away, they don't want to. Opposite, that's fine. But remember that your protons, those are basically tiny little magnets. They're just positive charge. Protons don't want to go together. So you need that heat, you need that pressure to smash and crush those protons, get them going so fast that they collide and get close enough to each other that the strong force, one of the other fundamental forces of nature, can take over. It's much stronger than electromagnetism, but it only works over tiny, tiny distances. So you push up the pressure, push up the temperature, and you're going to have more collisions possible for those protons. That will allow the protons to get close enough in the nucleus that they're going to stick together. After that, there's a few more steps before we actually get to helium, but that's the first step. That will get us to deuterium, heavy hydrogen.